So what I'm going to do tonight is I'm going to finish Chapter 8, Part 2. And we started that last week, and we talked about the linear functions. And so y'all remember how to graph straight lines, hopefully. And then we talked about the parabolas. And we talked about parabolas in the form of H and K, which is what we call standard form. And so remember, if anything is in standard form, and we're going to talk more about this tonight, but if anything is in standard form, then you can just look at it and basically find the vertex and graph it from there. So we talked about that. We're going to use that a lot tonight, in fact. And then this is where we got to. We got to the piecewise function. And tonight on your test, you do have a piecewise function graph, but you don't have to graph it, but you have to plug in those points, okay? So you should be kind of familiar with the domain, right? Kind of familiar with the domain. Okay, well, what I would like for you to do is I would like you to take your graph and divide it up into however many domains you have. So for example, we have 3 domains. We have 3 functions and 3 domains. So what I'm going to do is I'm going to take this coordinate plane and I'm going to divide it into these 3 domains. So for the first graph, it's only good when x is less than 0. So what I'm going to do is I'm just going to draw an imaginary line for x is less than 0. So that would be your y-axis. And then your next one is anything from 0 to 3. So we'll go here. And then your next one is anything greater than 3. So you have these 3 domains. Now, to graph this, well, tonight on your test, it'll help you that if you can visualize these 3 domains, then you can figure which x values go in those domains. So that'll definitely help you plugging in numbers. But for your graphs, what we're going to do is we're going to look at these graphs and we're going to graph them in their appropriate domain. So when you see this one, what kind of graph is this? Is it a straight line or parabola? Because those are the only 2 that y'all know how to graph. This is a parabola. Alright, so this is a parabola, negative x squared plus 2, and it opens down, and I know that because of that negative sign. But it has a vertex of what? The h is 0. We know that because there's no parentheses, right? And then the k is 2. So this parabola is only good for any x less than 0. Well, we have a starting point at 0, right? If it's at 0, then I have a point at 2. And it's going to be open, and it's going to be open because x cannot be equal to 0. So we're going to open that up. Now, like I said, it is a parabola that goes down, so if you want to do a t-chart for this one, that's fine, but you can only use x values less than 0. So let's say we choose a negative 1. Well, if we plug it, and you have to be careful when you do this, because it says the opposite of negative 1 squared plus 2. So that's going to be the opposite. Negative 1 squared is going to be 1 plus 2, which is going to give you 1. So you should have an ordered pair at negative 1, 1, and you can see how this parabola is going to go down. Okay? But notice that I went ahead and started with a starting point at 0. But I opened it up because 0 is not in the domain. There's no line underneath there. Okay, when you see this, f of x is equal to 2, what is that? Talked about it a bunch last week. It's a straight line, horizontal line. Yeah, it's a horizontal line going through the y-axis at 2. So we need a horizontal line from 0 to 3 going through the y-axis at 2. So it's going to look like this. And it's going to be closed because it can be equal to 0, but it's going to be open at 3. So you have a horizontal line going through the y-axis at 2, but it stops at 3. because that's where our domain is. All right, so let's look at this one. This one, again, we have a parabola. The vertex here is going to be 0, -7. But this time, we can't use 0 because all of our x values have to be greater than or equal to 3. So if we could use 0, then we know that it would be way down here somewhere, but we can't. So what we're going to do is we're going to start with x is equal to 3 and do a t-chart. So if x is 3, 3 squared is 9, 9 minus 7 is going to be 2. So I know that I have an ordered pair at 3, 2, and it's going to be closed here because it can be equal to. And then what I need to do is I need to find another point. So let's go ahead and plug 4 in. 4 squared is 16 minus 7 is going to give us 9. So we have an ordered pair at 4, 9. So now, imaginary speaking, because you can't do this, okay? Imaginatively speaking, this parabola would start down here, and then it would go all the way up through here. All the way up. So it would start down here, and then it would go all the way up through here. Okay? But since we can't use this point, we're just going to start it here and just go up and do the best we can, making it a parabola. It's not a straight line, it is a parabola. And that's how you would draw your piecewise functions. So basically what you're doing is you're putting 3 graphs all on one, but you can only put them in their certain domain. Okay? So these points are good starting points, and then anything in between. So that's how you graph a piecewise function. Let's practice. So the next thing we're going to do is we're going to talk about how to graph a quadratic that's not in HK form, that's not in standard form. What if it's in this form and it doesn't have HK? This is called general form, okay? If you have a quadratic that's in general form, you cannot just look at it and pick out your HK, okay? Number 1, we don't have parentheses. Number 2, there's no K, so this is not K. Notice it's C. If it's in general form, you cannot look at it and pick out HK. You can't pick out the vertex. So what you have to do in order to find the vertex is you have to use this formula. And this formula, if you pick it apart, it's not that bad, because what you're going to do in order to find the x coordinate, you're going to do the opposite of b over 2a. So where did the a and the b come from? Look, a is your coefficient of your x squared term, b is your coefficient of your x term, and then c we're not going to use right now, but c is that constant out there. Okay? So you're going to do the opposite of b over 2a in order to find your x coordinate of your vertex. And what this means is whatever you found x to be, you're just going to take it and plug it in up here and find your y. So that's how you're going to find your vertex. Opposite of b over 2a, and then take your x coordinate, plug it in here, your original function, and find your y. Once you have your vertex, what you're going to do is you're going to find your 2 other points. Now, a, that leading coefficient still tells you whether or not it opens up or down. All right, but what we're going to do is we're going to find intercepts, or you can still do the t-chart if you want to. But I do want to show you finding the intercepts either by factoring or by using the quadratic formula. I probably would not complete the square. But one thing that you're going to see in Chapter 9 and on your final exam is if it ever says find the zeros, that means find the intercepts, the x-intercepts. Okay? If the directions say find the zeros, I know it's on your final exam and you're probably going to see it on your Chapter 9 test. If it says find the zeros, you're looking for your x-intercepts. So for a quadratic, you're either going to factor it or you're going to use the quadratic formula. Do y'all remember the quadratic formula? X equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. I'll write it down for you. All right. Or if you want to use the t-chart and find those other 2 points, you can. Now, This is what you're looking at. This does not look anything like our HK form, does it? Our other formula had A times X minus H quantity squared plus K. That doesn't even look remotely like our other formula at all. So what we're going to do in order to find the vertex, to find the X coordinate, you're going to do opposite of B over 2A. So A is -1, B is 4, and C is -3. All right? So opposite of 4 is going to be -4 over 2 times A, which is -1. So we'll have -4 over -2, which is going to give us 2. There's your X coordinate for your vertex. Now, to find the Y coordinate, we're going to do F of 2. So where am I going to plug that 2 in? In for your X, right, in for your X in your original function. So everywhere you see an X, and again, don't miswrite that. Your base is just 2, so you got to take the opposite of 2 squared, plus 4x, nope, not x, plus 4 times 2, minus 3. And then if you do the math, what are we going to get? 1. And so your ordered pair for your vertex is going to be 2, 1. So we're going to have a vertex at 2, 1. Now, I think we have done a little bit of factoring in here, right? So if you wanted to factor this, you could. I would frown upon it because of that negative coefficient. But the other thing that you could do to find the intercepts is the quadratic formula, x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so to find those intercepts, the opposite of b is going to be a -4 plus or minus the square root of b, which is 4, squared minus 4 times a, which is -1, times c, which is -3, all over 2 times a, which is -1. So we'll have -4 plus or minus the square root of 4 squared is 16, and then that's going to be minus 12 all over 2 times 1, or -1, which is -2. So we'll have -4 plus or minus the square root of 4 over -2. So we have -4 plus or minus 2 over -2. Alright, so we're going to split that plus and minus sign up, right? -4 plus 2 is -2 over -2, which is going to be 1. And then -4 minus 2, which is going to be -6 divided by -2, which is going to be 3. And there's your x-intercepts. We have one at 1 and one at 3. So if it says find the zeros, that's what it's asking you to do. It's asking you to find those intercepts. You can either factor it or you can use the quadratic formula. In Chapter 9, we're going to do this with third-degree polynomials. And you just did it with a second-degree polynomial. Okay? So now what we're going to do is we're going to talk about transformations of some basic curves. So what we're going to do is we're going to learn 4 basic curves. Pure memorization, guys. It's pure memorization. But you have your 3x5 cards, right, for your next week's test. So draw these basic curves on your card so that you don't have to memorize them. Okay? Now we've already discussed that x squared, y equals x squared. You know that that's going to be a parabola. Okay? And a basic curve means that you don't have an h and you don't have a k. So the origin is always, or the vertex, origin, starting point, whatever, is always going to be 0, 0. Okay? If you don't have an h and you don't have a k, it's 0, 0. So the vertex for this one is going to be 0, 0. I don't have an h and I don't have a k. Now, on your test next week, I'm going to ask you to plot the vertex, the center, the turning point, whatever, and two other points. So for this one, you can use the T-chart and the mirror image. So if I choose 2, I'm going to get 4. And then the mirror image of it is going to be -2, 4. Okay? Now, same thing. If you see an x to the third, this has many names, okay? You can call it an S-curve, you can call it a Superman curve, you can call it up and away, whatever you want to call it, okay? I just call it an S-curve. Reason being is because when we get into chapter 9, it's going to make a crazy S anyway. So, again, this is HK form. I don't see an H and I don't see a K. So your center or your turning point is still going to be 0, 0. But this time, if I do the T-chart, we're going to plug in 4 numbers just to see what's going on. If I plug in 1, I'm going to get 1. If I plug in -1, I'm going to get -1. If I plug in 2, I'm going to get 8. If I plug in -2, I'm going to get -8. Okay, you're just cubing all those numbers. So if I graph these ordered pairs, you can kind of see why it's called up, up, and away, or your S-curve. The S is not really defined on this one. It's kind of stretched out, but the ones that we do in chapter 9, they're definitely going to be defined. So up, up, and away, S-curve, Superman curve, whatever. That's your third degree polynomial, okay? Memorization. All you're going to do, since I don't see an H and I don't see a K, all right? No parentheses, no number out there by itself. That means H and K is 0. No parentheses, H is 0. No number out there by itself, K is 0. So your starting point is going to be 0, 0. From there, just do your T-chart. Memorize S-curve. Okay, so that's 2 of them. The third one is going to be absolute value. Does anybody know what absolute value is? Right, it's going to make a V graph. V graph, V curve, whatever. Again, your vertex, starting point, center, whatever, is still going to be 0, 0. But what happens if you plug in 1? You get 1. What happens if you plug in 2? You get 2. What happens if you plug in 3? You get 3. So it goes up 1 over 1 every time. So let's go to the left side. What happens if you plug in -1? You're still going to get 1. What about -2? You're going to get a +2. What about -3? You're going to get a +3. That's absolute value. And there's your V curve. So if you see absolute value bars, understand it's going to make a V. Okay? Absolute value is going to make a V. And then the last one we're going to talk about, again, your starting point is 0, 0. But this is going to make a half parabola. But it's going to go in a direction that you've never seen before. Okay? My starting point is 0, 0. But all the parabolas that you have seen have either been a cup up or a cup down. This one's actually going to go to the right, but it's only going to be half of it. So let's make a T-chart and just figure out what it does. If I plug in 1, what am I going to get out? What's the square root of 1? It's going to be 1. Let's find numbers that we can take the square root of easily, okay? What about 4? We're going to do 2. What about 9? So you see that parabola forming? Okay. So those are your 4 basic curves that I want you to know. I want you to know the parabola. If you see an x squared term, it's going to be a parabola. I want you to know the S curve, third degree polynomial, the third. I want you to know your V curve, absolute value, and I want you to know your half parabola, which is going to be your square root, your radical. Okay? Now, every single one of these could possibly have grouping symbols. Okay? With these two, your grouping symbols would be parentheses, right? We've seen this written. It'd be like x minus 3 quantity squared or x minus 2 quantity cubed. Okay? If you see grouping symbols, you have an H. These two, your grouping symbols here are going to be your absolute value bars. And down here, your grouping symbol is actually going to be your radical. If there's a number inside the grouping symbols with the X, that is your H. Okay, if there's a number inside those grouping symbols with the X, that is your H. X and H always go together, always. So now what we're going to do is we're going to take these four basic curves and we're going to put it all together. We're going to take these four basic curves and we're going to use H and K to do a shift. And we call these quick graphs, okay? Because literally, you don't have to be very specific. I want the vertex, turning point, whatever, and two other points really quickly, okay? But you've got to know in your mind what it looks like before you can get it on the graph. That's where the memorization comes into play, or use your parts. Okay, so you know that if you have a function and there's a number out there by itself, that's your K. That's going to shift your graph up and down. K goes with Y. K is your Y, and therefore it's a vertical shift, up or down. And you're going to take K just like you see it. Okay? There's a plus sign in front of K, which means you're going to take K just like you see it. So if you have something like x squared plus 3, you know that this thing's going to be shifted up 3. Okay? Watch this. If you have f of x is equal to x squared plus 3, here's your K. So that means we're shifting up 3. Okay? Now, for h, if you have something like f of x is equal to x minus 3 quantity squared. This is your h. This means that we're shifting left or right. Got to take the opposite. When you're looking at it, it looks like you're going left, right? But you, according to the formula, you got to take the opposite of what you see. So this is a shift to the right. 3. Okay? So if you see those grouping symbols, if you see parentheses, absolute value bars, or the square root symbol, and the numbers in there or underneath, that is your H. And then the number out there by itself is going to be your K. H shifts left and right, opposite of what you see. K shifts up and down. Exactly what you see. Okay? So let's look at this. Here is your basic curve. What was this? What did it graph? It graphs a parabola. Look at this right here. Is this an H or a K? It's inside parentheses, so it has to be an H. That's memorization. If it has parentheses, absolute value bars, or whatever, and there's a number inside there, that's your H. So your vertex for this one, this is your basic curve. We've already graphed it. But this one, what is your vertex? Come on. 3, 0. 3, 0. All right. So we're going to take our basic curve and we're going to shift it to the right 3. You're going to shift it to the right 3. So to find two other points, let's plug in a number. What number can you not plug in? Yeah, we've already used 3, so you can't use that. So let's go with 2. So 2 minus 3 is negative 1, and negative 1 squared is going to give you a positive 1. So you have an ordered pair of 2, 1, and there's the mirror image. And so you took your basic curve and you shifted it to the right 3. You took your basic curve and you shifted it to the right 3. Okay, what about this? That is a K. So what is the vertex going to be? 0, -3. So a K is going to shift vertically, right? This one's going to shift down 3. This one's going to shift down 3. Okay? And then, of course, if you use your T-chart, let's plug in a 1. 1 squared is 1 minus 3 is going to be a -2. So you have 1, -2, and the mirror image. And if you practice this, it goes that fast. It literally goes that fast. I've been doing this for quite a few years, so I make it look easy. But if you practice, these are really, really quick. If you practice. You got to know what your H and K are, though, okay? What's missing here? What's missing in order to tell me that this is K? Grouping symbols. Yeah. All right. What curve is this? Which one is this? This is going to be your V curve because the absolute value bars. Okay? Your absolute value bars are acting as your grouping symbols in this particular problem. So do you have an H? Yes. There's a number inside those grouping symbols. So for this one, what is your vertex going to be? 2, 4. Opposite of H and take K as. Okay, here's your H and here's your K. So we're going to take that basic curve that we've already graphed. We graphed it when I was out showing you the basic curves. And we're going to shift it to the right 2 and up 4. To the right 2 and up 4. Now you already know it should make a V, right? So let's use a T-chart. And let's plug in 3. So if we plug in 3, 3 minus 2 is going to be 1. The absolute value of 1 is 1. And 1 plus 4 is going to be 5. So we should have 1 at 3, 5. And then it is symmetrical, so it does have a mirror image. So there's your V. So we took the basic V curve and we shifted it up, or to the right 2 and up 4. So do you see what H and K does? H and K are just shift markers. H shifts left and right, K shifts up and down. What about to the third? Which one is that? That's going to be your S curve. For this one, it's a turning point. Okay, it's not necessarily a vertex, but what would it be? Negative, we're over here. Sorry. -2, 1. I didn't move my pointer. -2, 1. For this one, yes, we would be at 0, 0. But for this one, we're going to shift to the left 2. Remember H? Inside those grouping symbols. So here's H. K is going to be out there by itself. So we're going to shift to the left 2 and up 1. To the left 2 and up 1. Now, on your S curve, you just got to remember what's going on. So if I plug in 0, what am I going to get? If I plug in 0, you're going to get 2 cubed, which is 8. 8 plus 1 is going to be 9. So you get 0, 9. Now, this one is symmetrical, but it's cut in half and flipped. So if I have an ordered pair, 2 units to the right and up 9, guess what? I'm going to have 1 2 units to the left and down 9. So it's going to be here. And remember what the S curve does. It comes in, goes through, kind of makes a parabola, and then cuts the other way. So there's your S curve. What is this one? It is a V curve, but look right here. There's a negative in front. What does that tell me? That it's going to go down. Because your normal curve, this one, goes up, right? So this one's going to go down. But we do have a shift. What is the shift? -3, -2, -3, -2. And since it's going to go down, we know that it's going to look like this. And you can plug in ordered pairs if you want to. So if you see a negative sign in front of your basic curves, what it's going to do is it's going to flip it, or make a mirror image of it, I guess, across the x-axis. Okay? So we're going to flip it across the x-axis. All right, last one. This is this one, and you know the parabolas where it's in general form, the trinomial, the one that we learned tonight? This problem right here and the general form parabolas are the ones that are most missed on the test that you're going to take next week. So take heed to that, okay? This problem and the parabola problems that we did tonight, the one where the trinomial, where you have to do opposite b over 2a, those are the #1 missed problems on the test you're going to take next week. So listen to what I'm saying, okay? If you see this grouping symbol, in this case it's a radical, and there is a number underneath that radical, what is that? That is your h. That is your h. That is your h. So h is going to be 1, and k is going to be 3. Your h is underneath, k is out there by itself. Same concept. Okay? So we're going to shift to the right one and up 3. And then you can do your t-chart. If you plug in 2, you should get 4. 2 minus 1 is 1. Square root of 1 is 1. Plus 3 is going to be 4. And it just keeps going. So you have that half parabola still. Now, for this one, because you're going to do a problem like this in just a minute. For this one, if there is a negative out front, watch this. If there is a negative out front, think about it. I told you it's going to be reflected across the x direction. Okay? So if I plug in a 2, my end result is going to be -4. My end result would be a -4. So what's going to happen? Well, no, sorry. If you plug in 2, 2 minus 1 is going to be 1, square root of 1 is going to be 1, but you got to take the opposite, so it's going to be -1, plus 3 is going to be 2, right? If you did the t-chart, and we're just pretending that there's a negative sign in front of there. If I plug in 2 this time, 2 minus 1 is going to be 1, square root of 1 is going to be 1, but you got to take the opposite, so it's going to be -1, plus 3 is going to be 2. So you would have an ordered pair of 2, 2, and so you can see that that negative sign flips it down this way. Okay?